Hello everyone. I hope the slides are visible to all of you. Myself Sana Sheikh. I am a fourth year PhD student at IIT Bombay under the guidance of Professor Santosh Ji Gharpure, and I am taking an NPTEL TA class of a course which is entitled as a Principle for Organic Synthesis, and the course instructor is Professor Punya Murthy from IIT Guwahati. So till now we have done the week 10 classes and today is week 11. So, as in today's class, we are going to discuss about the diazo intermediates, the reaction which is going through the diazo formation. We will look in this class, and also we are going to discuss about some rearrangement reactions. So, I hope I'm audible to all of you. Let's start the class. So, have you ever think about the diazo formation, how the reaction is going through diazo formation? So here we have one example, Sandmeyer reaction. The Sandmeyer reaction is given here. We have aryl amine. So here we have aniline, which is undergoing a reaction condition of sodium nitrate and acid along with the our aryl amine. Okay, so here or is written. So either we can use a third butyl nitroso compound or we have sodium nitrate. So how the reaction will proceed, we'll see here. First, the diazo formation will takes place. So this reaction is very basic and you have done in your BSc MSc time also. So how the diazo formation is taking place? Anybody can answer this one? So as you can see here, here, okay, we have Na2 and HCl. So if we will write in full form, NaNO2 plus HCl, what will happen? It will form HNO2. Okay. So, and salt formation will take place. NaCl. Got it? So, this is forming in situ, and this HNO2 will further react with the arylamine. I will write here. We can write this way also, right? NO2H. And we have another molecule of the same one. O and correct. So what will happen here? We have lone pair of electron on oxygen, right? So this will take up the proton from another molecule, and this will go like this charge. So what we will get, if it will abstract the proton, we will get NO2 O H H plus charge will be there on oxygen. Correct. Now after getting this one, as we know, H2O is good living, correct? So good living group will knock out and we will get NO plus. So plus charges on nitrogen. So if we will write in full, okay, sorry, if we will write this one way, so this will be the anion we will generate over here. Got it? Now after generating this NO plus, we know that this nitrogen has lone pair, correct? And it can act as a nucleophile. But here overall charge is positive, right? The species which is showing the positive charge will act as an electrophile, because in arylamine we already have nucleophile here, right? So this nucleophile will attack on NO plus this way. Okay, and it will form the intermediate, which will look like here, and H2 is there. Okay, so I'm writing here positive charge, plus charge. Okay, and it is attacking on N, so it will become this way. Now there is no positive charge, because if we will see here, this is the thing, right? So it will go like this, and we will get this intermediate. After getting this one, what is the next thing? See here, I'm explaining this as a formation here. So in other questions, you have to do this mechanism by yourself, because I'm explaining it once completely, fully. So you will be able to solve this by yourself. Okay. So let's move forward. Here, after getting this intermediate, what is the next step? Proton transfer. All of you know that we have done proton transfer n number of times. So here we will do the proton transfer, and we will get N H and O H. Proton transfer here to here. This lone pair is taking proton. Okay. So we can always remember, we have to show the arrow from electron flow direction, like from higher electron species, rich electron species to deficient electron species. So that's why I'm showing arrow from the oxygen to hydrogen, because hydrogen cannot give pair of electron. Oxygen can donate. So that's why always remember the nucleophile will always donate the pair of electrons. So arrow should be end at the electrophile and start from the nucleophile. Okay, this is the rule for arrow pushing mechanism. So after getting this one, we got here, now positive charge will generate over here, right? What's the next thing? Next is the lone pair of nitrogen will push here, and this will get up. So now you can see the next thing, N double bond and H O H. Got it? Now again we have to do the same thing, proton transfer here to here. Okay, so this will take the proton, and we will get here N triple. Sorry, I'm writing directly. You can write the step by step also. Okay, for your understanding, I will write step by step. Now, I hope this is clear till here. Okay, after getting this one, again, now we know the H2O is a good living group, right? So, and here we have nitrogen. So, nitrogen will push that lone pair of electron, and this group knock water minus H2O. So, here we have N triple bond N. So, this is the diazo we formed here, right? This one. Got it? Diazo formation. I hope all of you are clear till here. So after this diazo formation, now I hope this mechanism is clear, how the NH2 is getting converted to diazo intermediate. Okay. So after getting the aryl diazonium halide, we will next see the next step, where we have copper halide on arrow. Now here you can see the further mechanism. After the copper halide interacting with the diazo, diazo is a good leaving group, N2 is always a good leaving group. So it will knock out. Okay. And here you can see the electron will be generated. This is a radical mechanism. Radical mechanism. Okay. So copper here is in +1 oxidation state. When it's get inserted here, it will become in it will donate the electron, because copper has +1 oxidation and it's converting to +2 oxidation state. तो +1 to +2 जाने के लिए क्या करना होता है? क्या हो रहा है? ऑक्सीडेशन हो रहा है. ऑक्सीडेशन हो रहा है, दैट मीन्स इट्स गेटिंग रिड्यूस. सॉरी, ऑक्सीडेशन हो रहा है तो मतलब ये रिड्यूस करेगा. ओके. ऑक्सीडेशन हो रहा है, इलेक्ट्रॉन डोनेट कर रहा है. रिडक्शन हो रहा है, इलेक्ट्रॉन एक्सेप्ट कर रहा है. रिमेंबर दिस. ओके. सो हियर इट्स गेटिंग +1 to +2, दैट मीन्स इट्स डोनेटिंग इलेक्ट्रॉन, सिंगल इलेक्ट्रॉन. ओके. तो सिंगल इलेक्ट्रॉन डोनेशन कहाँ होगा? ऑन दिस डायजो कंपाउंड. सो हियर दिस इज शोन इन a bracket with one electron. Okay. And copper will become in +2 oxidation state. After this one, we know that this diazo is a good leaving group, so this will get knocked out, and we will get here phenyl radical. Okay, after getting this phenyl radical, we have halogen, which is in copper 2 complex we have seen here, right? So halogen donation will take place. So here copper 2 will get converted to copper 1. Right, here you can see x2, copper 2, x2 to copper x is a halogen, any halogen. Okay, so when it's getting converted to this one, so x radical is generating, and x radical will be trapped by this phenyl radical to get the aryl halide compound and product here. Okay, so this is the way we will get the product. So I hope you are clear with the mechanism. This reaction is known as a Sand-Meyer reaction. So let's quickly solve few examples. Here we have Meerwan arylation. Again, this mechanism is going via diazo. That's why I have included this in today's class, because today we are going to discuss about the diazo compounds. Okay. So what will be the mechanism? Here you can see the diazo species is given here, diazo, right? And here another substrate. And on arrow we have transition metal salt. Transition metal salt. In earlier also we have salt, right? Copper chloride was salt, transition metal salt. And minus N2 is diazo elimination is given it, correct? Let's see the mechanism. Diazo, after the diazo formation, the copper halide is here, which will donate the electron and it will get converted to copper 2. We have discussed this thing, right? Then after this formation of this intermediate radical formation, the diazo elimination will takes place. Okay, and we will get here phenyl radical. After getting phenyl radical, now this radical can act with the acrylate compound. So here withdrawing group is stabilizing this as a acceptor. Now this is a radical acceptor, right? So this radical will attack on this double bond, and here the radical generation will take place over here, which is a stable radical because of this withdrawing group. So if you will see, this radical is stabilized by electron withdrawing group. You can check the basic concept behind this one. So always the electron withdrawing group is stabilize the radical, same as a carbon ion, because radical is act as a carbocation also and carbon anion also. So because of that only this is getting stabilized. After stability of this radical, we will get the intermediate here like this. Okay. So after get this intermediate, now what's the next step? Tell me. Here it is given. Copper X2 is there. So it will again give the halogen. Correct? Halide. Sorry, halide. X radical will be there. This can be trapped by this radical also. But here this X radical, what is doing? It's abstracting the radical from here. So it will become X minus. Okay. And it will remain here. 1 second. Something is not correctly in this mechanism. We have X radical, which will trap here, and we will get here X. Okay. After getting this X in intermediate, which is not shown here, this will get the eliminated. This X will knock out, and positive charge will generate over here, which is a how the forget about this intermediate. Okay. So X is getting attached here, right? From here to here. After this one, this H halide will be knockout like this way, and double bond will be generated over here. This is ionic type mechanism. Till here we have radical mechanism. Okay, then last step is ionic type. So you can write in a radical type also, but this can possibly nanic type also. So here we get here double bond regenerated, right? So this is the product we are getting here, and this type of reaction is known as a Meerwin arylation. Meerwin arylation reaction. So because aryl group is getting attached at the place of hydrogen, correct? In this substrate. Okay. Next, Gomberg reaction. So here also you can see the diazonium salt, correct? Diazonium salt is given here. On arrow we have hydroxy OH minus. Now let's solve the mechanism. We have diazo compound here. Diazo formation I have discussed in detail, right? So no need to repeat it again and again. You just solve by yourself. After diazo formation, I am explaining the further mechanism, and which is the step where we are getting the different name reactions. Till diazo, everything is same. Okay. So after this diazo, we can see hydroxy group is there, which will react with diazo to form this intermediate. Okay. After getting this intermediate, we have another diazo molecule, correct? Which will further react with the this one and form the bis biomolecular intermediate. Two molecules are attached with this oxygen atom. Okay. Then N2 elimination will takes place. So if talking about the N2 elimination, if we will push here, it will go like this, right? And we will get this intermediate along with phenyl ring. So first they both will get detached, then we will get here N2 from here, and this will also knock out to give the benzene ring. Okay. After getting this benzene ring, and now we have another diazo in the system substrate. Okay. In the reaction system. Now after getting this intermediate, the next thing is this diazo will also knock out. And here radical formation will take place, which will trap the benzene ring to form the bicyclic ring. Okay. So here you can see that this radical, this radical will initiate here radical. Okay, H radical. This radical will trap the H radical and form the benzene radical. Benzene radical. Okay, from here, and it will become N2OH. Got it? This one after taking the H radical. Now this type of two radicals will form bond to give the corresponding product. Okay. So this name reaction is known as a Gomberg reaction. So now let's move to the next question. Sure annihilation. Here you can see the cyclization is taking place. And we have primary amine group here. Arylamine. Okay? This is the arylamine. And when we are treating it with NaNO2 and HCl, copper, we are getting here cyclization. So we will see the mechanism in detail. As all of you know that we have discussed this thing. NO plus was generating from this HCl and NaNO2. And after that, we know that nitrogen is going to attack on the NO molecule and it will give you a intermediate like this. After all those things, we will get diazo here. Because I have already explained this thing, I'm not repeating it again and again. But just remember here, we are getting here diazo. After this diazo, now we have discussed this again also, but still we have here copper, metallic copper, correct? Metallic copper. So copper is in zero oxidation state, so it can donate the electron. So it will donate one electron. This diazo will knock out. If this will not get a knock out, what will happen here? Plus charge will come, right? Because diazo is a nucleophilic electron withdrawing. So this plus charge will be then one electron will be donated by the copper. So as shown in previous example, we can write here better. We can show this way. Right. I will write here intermediate better. Because this is easy. With this bracket, we can show intermediate and electron here, which is donated by copper. Correct? So after this one, okay, after this one, we are getting this intermediate. This will not. Now, this intermediate will further undergo a radical cyclization where the radical will getting generated over here and here. Correct? And this will get cyclized. They will form the new bond and the new radical will generate over here. I will show this intermediate as well. Here you can see here another ring here. So this benzene ring is aromatic only. This will remain as it is. Here we have here. This way now here we have ready. Now aromatization will take place and we will get this as a product. Okay. So same thing is happening here also. So solve this mechanism by yourself. This reaction is known as a sure annihilation. Okay. Here we have H, right? So H radical will knock out and radical will form the new bond in the aromatic ring. So you can see in this case copper is plus again it's donating one electron. So here after getting this one electron will be donated by copper. It will become negative charge. Negative charge will push electron here and deprotonation will take place, which means minus H plus will give the aromatic ring. Okay. Now next one is Zapp-Klingman synthesis. Here again diazo is involved. We'll see the mechanism directly without wasting time. So here we have hydroxy ion, correct? Base, because here we have given base. So it can be NaOH, KOH, whatever. So OH minus will be there in the system. Okay? So base will always abstract the proton. You know that. So in this system, which one is the more acidic proton? If talking about, we can see the acidic proton at here also. Talking about our starting material, right? But this one is more acidic because it is sandwiched between the two carbonyl groups. So this proton is more electron acidic. Sorry, more electron acidic here. Sorry, acidic proton. Okay. Now it will be abstracted by the base and it will become here negative charge, or in we can write in a inlet form also. We have discussed in week 1 class. Okay, you can go and check that class also. So after here negative charge generation, it will attack on diazo compound. We have here diazonium salt, correct? Here. So it will attack on diazo compound. Initially we were seeing a aniline or primary amine was attacking on diazo. But here this is a different case. Where nucleophile is attacking on diazo, but this is a carbon nucleophile, carbon anion. Okay. After this one, we are getting this intermediate, which is shown here. Now, what's the next step? Next step, we have another hydroxy ion in a system, which is the base given by base, right? Base is there. Base will attack hydroxy ion, act as a nucleophile, attack on carbonyl center. It will get open up and will give this intermediate. Now, after getting open up, this lone pair negative charge oxonium ion, sorry, this negative charge will push electron here and the leaving group will knock out, which is this one. Compared to the hydroxy group OH, this group can easily eliminate. Okay. So this will get eliminated and we will get the acid plus another intermediate. Okay. So this oxygen ion will push electron and it will form this way. After this one, what is the next step? This acid have acidic proton, which is this one, correct? And this group have electron withdrawing group nitrogen and manganese, which can abstract the proton, which can act as a nucleophile. So it will abstract the proton from acid and it will become NH. Okay, and CO2 elimination will take place. This ion elimination will take place. So here we are getting this as a product. In this case also this one. This is the way the reaction will proceed. You can solve the another question by yourself, which is nothing but the same will follow the same mechanism just for your practice. Okay. Now the next thing is rearrangement, Damjano rearrangement. This is a type of rearrangement but involve the diazo formation. That's why I have involved this reaction here. I have included here. Okay, Damjano rearrangement. So in this case, what's happening? Ring enlargement, ring expansion, we can say, of amino-methyl cycloalkanes with the treatment uh, of nitrous acid to give the cycloalkanols. Here they have mechanism. Okay, suppose we have here here the question in question we have 4-member ring, but for example we are taking here 5-member ring. Okay, so this one you have to do homework. I'm explaining it in 5-member ring. So here you can see uh, we have nitrous acid, correct? Now lone pair of nitrogen will always act as a nucleophile. We have seen in previous examples. It will attack on nitrogen and this bond will get open up and it will take up the proton. Correct? After taking the proton, it will become this as an intermediate. Okay? Because this reaction is in acidic condition, proton is available. So proton is taken by this oxygen atom to give the corresponding intermediate. Now, the lone pair of oxygen, sorry, this proton will get abstracted because balance should be there in all the reaction. If protonation is happened, deprotonation will also take place. Okay, so this bond will push here and it will get knockout H2 by taking the proton transfer. We can say also proton transfer. Okay. Now after the elimination of H2O, we'll get this intermediate and after getting this one, it will form diazole. Mhm. ठीक है. Okay. So sorry for the interruption. I was getting a call. Okay. So till here we are getting the intermediate, correct? What is the next? Next, diazo formation will take place. How the diazo formation is taking place, we can see here. This nitrogen lone pair will push electron here and then it will take the proton. It will become an H here. H will be there and then proton transfer will takes place. Then H2O will become good living group and we will get diazo intermediate. It's all by yourself. I have done these things. So proton transfer is taking place in these reactions and we'll get diazonium salt. So after this one, diazonium N2 is a good living group. So from here, the migration of the group will takes place and it will get knockout. So how the migration is taking place, I will show here. 5-member ring we have, correct? After the diazonium elimination, here plus charge will generated. All of you know that the primary carbocation is less stable compared to the secondary one, correct? Secondary and tertiary are more stable. So that's why the migration will take place in Wolff-Kirshner rearrangement and other rearrangement, pinnacle rearrangement. We see this pattern. So the migration will always taking place, and we will get here secondary carbocation generation, which shown here. So correctly shown. Correct? This 6-member ring. Now again protonation will takes place. Positive. Sorry, not protonation. Here, attack of nucleophile will take place. Water will act as a nucleophile and it will attack here and then it will become hydroxy group. So hydroxy group will come over here. So because this reaction is proceeding under the presence of water molecule, that's why water is acting as a nucleophile here. And we are getting our alcohol as a product. So I hope you understood the mechanism and you will solve this by yourself. And what is this side product? If after getting this carbocation, this will be directly trapped by water molecule. So we will get here side product, which is this one, correct? And this is a very minor product because stability of this carbocation is very less, but it will be there in reaction because this is cannot be avoided completely. That's why we'll get the byproduct also. So plus this one, minor, and this is the major, right? Next, the major product of the reaction is here we have again acid HNO2 here we have, right? Here also we have nitrous acid, copper bromide, and acidic condition H2. We'll see the mechanism. Now till diazo everyone is clear, right? This is going to attack on, right, this one, and we'll get diazo. Okay. After diazo formation, what is the next? I have explained you in earlier case also. Radical formation will take place this way. Electron donation will take place. Correct. Radical will come here this way, and then this group will get eliminated. We'll get here F रेडिकल. ठीक है, यहाँ तक क्लियर. Okay. After this radical, what is the next thing? Reductive elimination. This will form like a complex. Okay. So reductive elimination will take place. First, it will form the complex. I will write here complex. So reductive elimination will take place. So we have here on copper, we have 2Cl. Right? So reductive elimination will give me halogen atom here. Right. Sorry, in this case we have bromide. I should have written here bromide. This is the product we are getting here. And copper bromide will regenerated. Okay. So regeneration of copper bromide is taking place here. Regeneration of catalyst. So this is the mechanism we have shown here. And this reaction is known as a Sandmeyer reaction. We have discussed this one, right? Which is invented by the German scientist, German chemist Traugott Sandmeyer. Then let's move to the next question. The major product of the reaction is, again we have NaNO2 HBr. NaNO2 will form the diazo, so I will write directly diazo here. what else? Okay, till here everything is aware, right? After this diazo, what's the next one? Radical. So electron donation will take place, right? From copper, and copper will become copper chloride, chloride and bromide, because here Hb are in use. So they are will be given to the copper. Okay. After this one, this diazo will knock out, and we will get radical here. So I'm writing this as a R group. I'm not going to write all these things because this is the part where nothing is happening. And here we have radical. Okay. Here like this radical formation it takes. After this one we have methyl acrylate. Right? Methyl acrylate is given. So this methyl acrylate half arrow. Always radical mechanism is shown by half arrow. Okay. So that's why we will get here this radical is stabilized by this group, withdrawing group. And now we have copper chloride bromide, right? It will form complex, reductive elimination will take place, and bromide radical will be donated. And it will become bromo CO2Me, and copper chloride will get, sorry, copper plus one, regenerated. Okay, regeneration of the catalyst. So this is the mechanism of the reaction, and this name reaction is known as a Mirvan reaction, which is the name after Hans Mirvan, a German scientist. Okay. So correct answer is here. We are getting this group here. Here I will write R. Okay. So aliphatic carbon replacement is taking place. Next one. The major product of the reaction is, till now we were doing the amine to diazo conversion. Okay? Amine to diazo conversion. But here we have given the nitro group. So have you seen any reaction where the nitro to aniline, amine conversion is there? Any reaction? Remember? So go and check your reaction. If you will see these reactions, nitro is easily getting converted to amino group. So here we have mechanism. First I will show the mechanism, then we will discuss that thing. So here the replacement of aromatic carbon is there, correct? Which is known as a Shor reaction. We have discussed Shor reaction right now. तो क्या होगा पहले? We know that acetic anhydride is there in our reaction. So we have here it will abstract the proton from here. Negative charge will generate. It will attack on the carbonyl carbon of aldehyde, and this is the aldol type reaction. Okay, aldol type reaction will take place, and aldol condensation. So double bond will come here with condensation. Go and check the week 1 class. You will get this mechanism. After getting this intermediate, what will be the next thing? This nitro is getting converted to amine. How? So first electron pair donation will takes place. HNO2 is given here. It will form an NH2, and then that NH2 will get converted to diazo by this. So H2 reduction is given, right? H2PDC. Nitro to amine reduction with H2PDC is well known. It is homework for you. If you are not able to solve this one, I will solve in class. So you can ask me next class or on a comment section on YouTube. So this is the well-known reaction. You have to do this by yourself. Okay. So amine formation will take place. Then after that amine, we have discussed the diazo formation, right? Then diazo will form here, and then this diazo is a good living group. You know that. So this will knock out, and here radical will form. And aromatization will take place to give the phenyl 3. Okay. Sorry, this is the ionic mechanism. So here positive charge will come. Then the proton abstraction will take place and it will attach here to form the phenyl 3. This is the correct answer. Next, the major product of the reaction is. So here we have nitrous of group, and here also we have amino. Already amino is there, so it will become diazo. You can know that, right? Diazo formation will take place. I will write here. And after that diazo elimination will take place, followed by cyclization. We have discussed this reaction n number of times, so we will get this cyclized product. So here option number 2 is the correct one. This is also for your practice. Solve this by yourself. We have done this example many times. Okay. Next, the major product of the reaction is, again we have diazo. Okay. So mechanism is given here. Okay. What will happen here? Here we have ester group, correct? And amide group. So in ester and amide, ester is more reactive compared to the amide, because many of you will ask why the reaction is doesn't happen at this center, because this is the amide group which is less reactive compared to the ester one. Ester is more reactive. And in this example, we have ketone and ester group, so that's why ketone is getting reactive. Okay, preference here given to the different functional group. So here we have given preference to ester. Okay, so base is given, right? So first of all, what we have to do, we have to write the base will abstract the proton and form the here negative charge or inhalate, which will attack on this one nitrogen. Cl will knock out, and we will get intermediate, which will look like this. Okay, till here, all of you clear? This hydrogen formation will takes place, and after this, what is the next? We have base, correct? It will further form the inhalate. Here is shown We have this diazo. Diazo is getting attacked by this group, and we are getting this type of intermediate, correct? After this one, base will again hydroxy group will attack on carbonyl center here. So it will attack on this carbonyl center if we will have, yes. So another one will remain untouched. Here we have, it will become OH, 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 correct? Oxygen ion, because OH is attacking. This oxygen ion will push electron here and this group will knock out. So we will get acid. Sorry. This will push electron and this group will knock out because this is a more electron, more good Lewin group. Okay, compared to the ethoxy ion. Sorry. I have made one mistake. One carbon extra I have written here, which is not there. This way. Sorry for this one. Okay. So oxygen ion will push electron here. This way. After this one, it will conjugation is more stable form. So it will get in conjugation form. And we will get proton transfer mainly. Basically, proton transfer is taking place and we'll get this as a product. It is a Jap-Klingman reaction. The name reaction is Jap-Klingman. Option number A. Okay. The major product of the reaction is, here also you can see the basic things on arrow and you know how the reaction will proceed. So here we have aniline group and here and so we have to form the diazole. Whenever you see this combination, you have to make the powder. Okay. Diazonium salt formation will take place. After this diazonium salt formation, what is the next thing? This will push electron here. And this will knock out. You will get directly product. This is the name reaction. Technev Damgeno rearrange. Okay. So this is the reaction I have discussed here, but you have to do this step by step. So this is homework for you. Got it? Tifner Damgeno rearranging it. Got it? Okay, next. The major product of the reaction is, here again we have HNl2, acidic condition H plus. So whenever we see this one, we have this one, we have to make the diagonal. This, remember this one. Till here, we have to solve this. ओके, डायसो बन गया एक बार उसके बाद हो गया। ठीक है, we can write this as one as this form also. Correct? Now, no need. Here, we have this group, enemy 2. ठीक है? Correct? Go to H and here it is in conjugation, correct? So from that will come here, this will go here, this will go here, and it will attack on this one to cover this, and we will get this other cover as shown in this mechanism. Okay. Then again, the rearomatization will take place to get the corresponding group. Next, which one of the following is an example of modern dye? So modern dye is a orange red dye, orange color dye, which is done by experimental section in BSc only. So I hope everybody is known about the dye, so modern dye. So this is the experiment included in our BSc practical. What is the correct structure? I'll show the structure directly here. This. Okay. Because it has to bind with the binding agent and form a complex. That's why, and complex you can see only in this case. That's why this is the modern dye. Next. Now let's move to the rearrangement reaction side. Okay, till here we have discussed the diazole salt and diazonium salt formation and mechanism reactions involving those diazonium salt formation. Okay, now we are going to discuss the Wagner-Milman rearrangement. We are covering here rearrangement reactions. Okay, so you can see that acid catalyzed rearrangement is this one is the acid catalyzed rearrangement where the alkyl group migration is taking place. So here we have alcohol, secondary alcohol. So protonation will take place because it is in acidic condition. So H2O will become and H2O will become good living group. Carbocation generation will take place. As I told you, where in sorry by mistakenly I have named wrong there. Wolfrational arrangement नहीं Wagner Milman rearrangement है ये. So now here the alkyl group chain migration will take place and because secondary carbocation is less stable compared to the tertiary one, so it will try to become a tertiary carbocation. That's why the group migration will take place. The driving force is here the stability of carbocation. So after the migration, the carbocation will generate over here tertiary carbocation, which will take the proton to sorry then proton deprotonation will take place because protonation has done earlier. So balance will be there. So that's why deprotonation will take place and double bond will generate over here between these two carbon. So this is the rearrangement which is known as a Wagner-Milman rearrangement. Okay. So next is the pinnacle-on rearrangement. Let's talk about this one. So in this case we have diols, vicinal diol. Okay. So we are having vicinal diol. So this is also in acidic condition. So protonation will take place on any of the hydroxy group. So after that protonation, what will happen? It will become good living group and H2O will get knocked out after this one. So carbocation will generate over here. ठीक है यहाँ तक. After this one, this group will get migrated. Migration will takes place and it will become. It is shown here migration. After this carbocation formation, migration of CH3 will take place and this will form a carbonyl group and we will get this as the intermediate. After deprotonation, we will get the corresponding ketone as a product. So in this reaction, acid is to protonate the hydroxy group and making it a good living group. Then after the good living group, carbocation formation will take place. And then the key step in this formation is pi bond migration of the carbon atom. So here pi bond formation and the migration of carbon atom. So this is the pi bond formation is taking place and this is getting migrated. So with unsymmetrical diol, the key factor in determining the major product is the 2 hydroxy carbon will form the carbocation more readily. So migration aptitude is there. Which group will form the undergo a migration? This depends on a different group attached to the hydroxycarbon atom. Okay. So next is the Drewp rearrangement. I think this one you have not heard. So Drewp rearrangement is the acid catalyzed rearrangement of tertiary acetyl acetylenic alcohols. Tertiary alcohol here we can see this is tertiary acetylenic alcohol leading to the formation of alpha beta unsaturated ketone rather than the aldehyde. Okay, so we'll see the mechanism here. First protonation we have to do. It will become H2O, which is good living group. Then after the good leaving group elimination, we'll get carbocation generation over here. Then deprotonation will take place and double bond will come over here. We'll get this enwine, enwine intermediate, correct? After this one, protonation will take place. And the protonation will make this center this carbocation generation, which will be trapped by water to form the hydroxy group at second position. Now, this is the enol form. We know that. So, keto-enol tautomerization will result in a formation of ketone, which is alpha beta unsaturated. Okay. So, mechanism is given here also. So, whenever you have this type of acetylenic alcohols, you have to protonate the alcohol. After the protonation, it will become the good living group, and elimination will result in a carbocation generation. Then deprotonation will form the double bond over here, and then after getting this acetylene intermediate, it will again, because acidic condition is there, it will again take the proton and form the carbocation generation at the here position, this position. Then this carbocation will get trapped by water molecule because earlier water is eliminated, right? So water will trap this carbocation and deprotonation will takes place to form the enol intermediate. Then ketoenol tautomerization will result in the product college. So I hope mechanism is clear to you. This is a rearrangement reaction, which is very simple, but the practice is required. Courteous rearrangement. Okay. So in this case, we have N3, right? N3 salt. Now N3 will attack on the acid chloride. We have acid in courteous rearrangement. We have acid chloride, and N3 is reacting as a nucleophile. It will form this intermediate. Now this oxygen ion will approach electron, and this Cl minus will knock out. Got it? So after this one, we are getting this acyl azide intermediate. Okay. This azide will rearrange. Now you can see this negative charge will push here and it will form the intermediate which will look like this one. Now as and 3 is a good living group. Azide like diazo also, like diazo, and 3 azide is also a good living group. In heating condition it will knock out. And we will get nitrine intermediate. Nitrine intermediate is also written like this. This is also okay. Nitrine intermediate. Okay. And to elimination, what are diazo and to elimination and to is a good living group, right? We have discussed this one. So nitrogen formation will take place. After that one, here it is shown in a orbital form, orbital form. So you can see here the sp2 nitrogen atom is sp2, and it will form isocyanate. Rearrangement is taking place. How the rearrangement is taking place? This R group is getting migrated on nitrogen and it will form this way, carbon. ठीक है? And here R group migration होगा. Nitrogen के बाद R group migration will take place and this will known as a isocyanate. Isocyanate formation is taking place. After that one, isocyanate formation, depending on the nucleophile, we getting the different products. So suppose if we have alcohol in reaction mixture, alcohol will attack on this center, electrophilic center. ठीक है ये वाला this one. Okay. So it will if it will be trapped by water, then it will become acid. If it will be trapped by alkoxide ion, then it will become ester. And if it will be trapped by amine, then it will become amide type of group, by keeping this as a constant. Okay. And after getting this acid, the CO2 elimination will take place and it will give you a amine. Okay, amine. So the next one is a Lorentz rearrangement. So because this rearrangement proceed via same intermediate, that's why I have discussed here isocyanide intermediate. Okay, this one. That's why we have added here. So in this Lorentz rearrangement, we have XCl group where X can be a acetyl group, SO2R or anything. So basically we have here fluoro group, right? And here we have this starting material where what will happen in this case? The halogen proton exchange will takes place. Sorry, not halogen. This lone pair will attack on this one and Cl will be knock out. Okay? And we'll get this intermediate. After this one, now proton abstraction will takes place from base. This is a basic condition. So H2 elimination will takes place and we will get this as an intermediate. After this one, we know we can write this as this is a resonance form of this one. So we can write this way also. And then the oxygen ion will push electron and it will knock out. So we will get isocyanate intermediate. After this isocyanate intermediate, water is there in reaction which will trap the electrophilic center in this isocyanate group and it will form intermediate like this. Okay, water. Then proton transfer will take place and we will get the corresponding acidic group here. Functional group and a CO2 elimination will result in a formation of primary amine. So in both the cases, primary amine formation is taking place via same intermediate isocyanate, but the starting material is different in both the cases. Okay, starting material is different. One is going via azide formation, and the other one is in basic condition with different groups. Now talking about the Smith reaction. This is also similar like the Curtius rearrangement, but here we have starting with the acid. Acid is getting protonated in acidic condition and it's become the H2O leaving group. Then we will get here ketene. Ketene as an intermediate. Then this ketene will further react with the azide group and will form the this intermediate. Correct? Because we can write ketene in this form also. Everybody is aware of this one. So this nitrogen will attack over here and it will become like this. Okay. After this one, N2 elimination will take place, which is a good leaving group, and we will get this here isocyanate intermediate. Sorry, isocyanate intermediate. Then this isocyanate intermediate will further trap by the water molecule here in this form, and it will open up. And after this one, protonation will takes place, proton transfer we can say, to give the this intermediate. Then this proton transfer, after this proton transfer, this intermediate will form. Then deprotonation will takes place and oxygen ion will push electron here and this group will knock out, which is the primary amine. So in this case also we are getting primary amine followed by CO2 elimination. The next one is Hoffman rearrangement. Okay. Hoffman rearrangement में क्या amide से start करना है. We have to start with the amide and we have here basic condition. NaOH is given here and dihalo compound. So here bromine is given, bromine. Okay. So in this case, basic condition is there. So proton extraction will take place first, and after the proton extraction, we will get this intermediate. Then this negative charge will act as a nucleophile and will trap the uh, Br ion, and Br minus will not. Okay. So it will take this one. After getting this one, we are getting this intermediate. And further, we have basic condition, right? So base will be there, which will abstract the proton from here, and negative charge will generate it on nitrogen atom. Now this negative charge is in intermediate is in resonance with this, right? So this oxygen ions can form here, and which will give you the nitrine intermediate. It's the nitrine intermediate. All the reaction are going via same intermediate formation. That's why we have discussed here. So after the nitrine intermediate formation, isocyanate will form here, right? This group will get migrated. So here also you can see this group was getting migrated, right? So this group will getting migrated and we are getting isocyanate intermediate. After this one, what is the next thing? Water attack, right? In all the cases, whenever we form the isocyanate intermediate, water molecule is attacking on the electrophilic center of isocyanate. So here water attack will takes place and then proton transfer followed by CO2 elimination will result in the formation of primary amine. All mechanisms are similar. So just remember the starting material where you can distinguish between them. The next one is Baer-Villiger oxidation. So MCPBA is where lone reagent for epoxide formation. All of you know this one. But here, this is a Baer-Villiger oxidation where the epoxide formation is not taking place. Whenever we have double bond, that time MCPBA will act as a epoxide reagent. But when we have carbonyl carbon center and there is no double bond, that time MCPBA act as a Baer-Villiger. MCPBA undergo a Baer-Villiger oxidation reaction. So here we have per acid MCPB, metachloroperbenzoic acid. ठीक है? The full form of MCPB is metachloroperbenzoic acid. It is the per acid. We know that it will react with the ketone in our group. Okay, our reaction sources. So it will protonate the ketone, and after the protonation, it will become this. Correct. Then the peroxide attacks the more electrophilic carbon atom. So here electrophilic carbon atom, this one peroxide will attack here and it will form this intermediate. Then formation of the Krejci intermediate. This intermediate is known as a Krejci intermediate. Yeah. ठीक है, Krejci intermediate. Then after this one of the substituents from the ketone migrate to the oxygen of the peroxide group. So here this R group will get migrated. This OH lone pair will push electron here and this group will knock out. Okay. And this R group will migrated on this oxygen atom and this group is knocked. Then deprotonation will leads to the formation of esters. So यहाँ पे क्या हो रहा है? First of all ये intermediate बन रहा है. After this one ये lone pair of oxygen will push electron here, right? यहाँ पे ketone आएगा तो ये R group eliminate होगा which will be taken by migrated on this oxygen. ये oxygen पे migrate हो जाएगा. ठीक है? After that migration we will get and elimination of this group. CO2 elimination or R group. Okay, so that's why we are getting this intermediate. This group elimination takes this way. And we will get here ester formation. So this is a bare vinegar oxidation reaction. Next one is Dakin oxidation. We'll discuss this one also. Dakin oxidation में क्या होगा? Same like bare vinegar. This is also peroxides. So we'll see the mechanism here. Always this will attack on a electrophilic center and will form the tetrahedral intermediate. This tetrahedral intermediate then undergo a aryl shift. So this oxygen ion will push electron here, and that time one of the group will get migrated to the oxygen. In previous case also this was happening, right? So after this migration, this group will get knockout OH hydroxy 1 and will get O-octyl phenol, right? O-octyl phenol. Then after this formation, the OH minus which is eliminated will again attack on a carbonyl center and it will form the intermediate this way. Then another hydroxy group will take the proton and it will form this intermediate. Then lone pair will push electron here. This will knock out and we will get the alcohol as a product. Okay, alcohol as a product. So this is called a hydrolysis step. Substituted phenol. So first the reaction is giving the bare vinegar type product, then further hydrolysis will result in a formation of substituted phenol. Okay. Next, Somlet-Hauser rearrangement. So here we have tertiary benzylic amine, which is undergo alkylation with this haloalkane. Okay. So what's happening here? So in this case, we can see this nitrogen lone pair is attacking on this one, and this is knockout. We'll get this benzyl quaternary ammonium salt as an intermediate. Then we have base also. Base will abstract the proton, acidic proton. So here it will abstract the proton from here. And negative charge will generate here, which is known as a nitrogen halide. This is the halide. Okay. And this halide will undergo a rearrangement to give the substituted tertiary benzylic amine. So how this happening? ठीक है? And we are getting this rearrangement to get the substituted tertiary benzylic amine. So in this mechanism, Somlet-Hauser rearrangement, first step is the formation of nitrogen halide intermediate, which is generated from the benzylic quaternary ammonium salt by removing the acidic proton with the base. Okay. Then the next step is the sigmatropic rearrangement. We can write this way also. Suppose they are double bonded, right? Positive charge, negative charge. So 1, 2, 2, 3 sigmatropic rearrangement. 1, 2, 3, 1, 2. ठीक है. So 1, 1 का bond break होगा. 3, 2, 3 sigmatropic rearrangement will undergo and it will give you a product, substituted tertiary benzylic amine product. Okay. Clear? Next. फिर इसकी rearrange. So in Fibonacci rearrangement, ring contraction is taking place. So first step is the deprotonation and formation of enolitine. So where the deprotonation will take place? Always the acidic proton. So here we have acidic proton in this case. Yeah, ठीक है. Okay. So after this one, oxygen and electron push, and this one will attack here. This will knock out. Okay. Till here, all of you got this one. Then we have nucleophile. Nucleophile will attack on carbonyl center. So nucleophile will attack here. It will get open. And we will get here O minus, oxygen and nucleophile. Here we have two groups. Got it? Now we have base. This oxygen ion will push electron here and it will get open. Sorry, I forget to write here once. ठीक है. ये हो गया. ये हो गया. And nucleophile. Here we have this. So this is the product we are getting in this case. So the first step is deprotonation and formation of the enolate, then cyclization of the enolate generate a cyclopropane intermediate. Then after the cyclopropane intermediate, nucleophilic attack is taking place by the nucleophile. And the last step is protonation leads to the ring contract product. So in this case, ring contraction is taking place, but here we have open chain. That's why we are getting this is a product. I hope this mechanism is clear to you. In this case, the mechanism is the going via cyclopropane intermediate formation. Okay. Next one, Wittig reaction. So Wittig reaction is very famous and well-known reaction. We'll see the mechanism here. Whenever we have phosphorus halide, this is the phosphorus halide. Okay. So it will attack on a carbonyl center. Okay. This way. So it will form the intermediate. So here we have halide. This halide. halide कैसे बनाते हैं? It is given here. PPH3 डालना होता है. कोई भी हेलो अल्केन में. That time it will become like this way. And base will extract the proton to form the halide. And after the halide formation, this halide, then this will attack on this. यहाँ पे दिया है. So this way, and it will open up. So it will form this one. So preparation of the phosphonium salt is given here. Then formation of the phosphorus halide by the base. Then the third step is the nucleophilic addition. Leads to the formation of the betaine. This is known as betaine. Okay. So this is betaine. Okay. Then it will form the oxaphosphetane. Oxaphosphetane. Okay. 4-member ring. Oxaphosphetane. And then this oxaphosphetane will undergo elimination of triphenyl phosphine oxide halide to give the Z alkene as a major product. So depending on the halide, we are getting different Z and E alkene. So whenever we have the withdrawing group which is stable halide, it will give you E alkane. But whenever we have destabilized halide, phosphorus halide, that time we will get the Z alkene. So here alkyl group is there, that's why we are getting Z alkene. But if we have withdrawing group on this carbon, that time we will get E as a product, major product. Okay. So there is a well-known reaction, Wittig reaction. Now the next one is Miss-Sonobu reaction. So in Miss-Sonobu reaction, triphenyl phosphine is used with the dead. Okay. So we are going to end here. Now this is the last section I'm discussing today. Then the remaining thing we will discuss in the next class. Okay. Now here you can see triphenyl phosphine is there, which will attack on the this nitrogen of dead. Okay, dead nitrogen of the dead molecule, and it will form the intermediate this way. So after getting this intermediate, this is also a halide type intermediate. Triphenyl phosphine react with that to produce the betaine intermediate. This is betaine intermediate that deprotonates the nucleophile. It will deprotonate the nucleophile and it will form the this way. Nucleophile is here. Formation of oxyphosphonium anvil takes place. Then it oxyphosphonium anvil takes place here like this way, and then nucleophile will attack on this carbon and this group will knock out. Nucleophilic attack will take place in a SN2 fashion. SN2 reaction will take place to give the panel product. So thank you so much for your kind attention. Till here we know that different rearrangement reaction we have discussed and different reaction which involve the diazonium salt formation. Okay. So if you have any question, any doubt regarding today's class, you can ask me on the comment section on YouTube also, or either you can ask me in the next class, which will be on Friday from 7 to 9 p.m., which is the week 12 class. Okay. Thank you so much for your kind attention. See you in the next class.